Last time you learned the anatomy of a figure, fig, axis, artists, the scaffolding. Now you'll point that scaffolding at real data. Before you model, you look: one scatter, two histograms, one box plot, and the structure that decides whether your model even has a chance shows up before you train anything. Here are two classes, 300 points, drawn from two Gaussian blobs, plotted raw as a single color. It's a smear. A cloud. You can't tell if there's any structure at all. This is what "I'll just trust the accuracy" looks like before you plot. Now color by class. Cyan for class 0, magenta pink for class 1. Two blobs separate out, one lower left, one upper right, with a fuzzy overlap zone in the middle. The scatter already tells you, separable but not cleanly. A linear boundary would miss some. Slide a histogram onto each margin. The top one is feature 1, the right one is feature 2. Each shows two overlapping humps. Where the humps pull furthest apart, that feature carries the most signal. Watch feature 2, its humps separate more than feature 1's. Finally, a box plot, one box per class on feature 2. The boxes, median, quartiles, whiskers, sit at clearly different heights with only a small overlap. That gap, 2.36 units between the medians, is the structure a single metric would have averaged away. Here's the program: seed with default RNG 7, draw class 0 around 2, 2, class 1 around 4 and 4.5, concatenate into X, Y and a label array. No download. The data is born in NumPy. We compute the per class means with a Boolean mask: X where label is 0, X where label is 1. Same for the feature 2 gap. These four numbers are what the plot must agree with. The figure is not decoration, it's the same arithmetic. Layout. Pelty.subplots gives the main scatter, and we add two marginal axes for the histograms, sharing the scatters X and Y. Ax.scatter takes C equals label, so color is the class. Each margin gets ax.hist with two calls, one per class. Run it twice and assert the arrays are identical. That's the reproduce check. Then we assert the gap drawn on the figure equals the gap printed to the terminal, rounded to 3 places. If the plot ever drifts from the numbers, the script fails loudly. Read the terminal. Class 0 sits at feature 2, mean 1.915. Class 1 at 4.278. The gap 2.363. Feature 2 separates better than feature 1. 2.36 versus 2.08. And the figure. The scatter shows two colored blobs. The right margin histogram shows feature 2's two humps, pulled apart by that same 2.36 gap. Eyes and arithmetic, one picture. The punchline: plot before you model. EDA shows you structure, overlap, and which feature carries signal before a single epoch. Next episode, we plot the results: confusion matrix, ROC and PR curves, seeing whether the model honored the structure you just found.